Prova, prova. Guido, ci sei? All right. I guess I can stay here. Okay. All right, thank you very much, and welcome to the second day of the kickoff. It's raining. We did it on purpose so that we stay here. We don't go outside seeing. The whole day we'll be staying here in the theater. We'll have lunch just in the restaurant beside the theater. So we did it again, not to move too much from here. Besides the jokes, we will start as written in the program with the 10 demonstrators, so presentations of the 10 demonstrators. And then, as written in the program, after a coffee break, we'll have the innovations fair, internal innovations fair. In the material we gave you when you arrived, there was also this. This is a single sheet of paper. Internal innovations fair instructions. So I suggest you read it now while the others are presenting, because it's instructions. So I'm not going to read it now, but and we will have it anyway upstairs. We are setting up the stage upstairs for the innovations fair. So please read the instructions so that you are ready to go when, in a couple of hours, we will start the innovations fair. And without further ado, I guess I can call on stage the first presenter. We have the first demonstrator. We will go in the order that we used for the proposal, DEM 1 up to DEM 10. DEM 1 is Valencia City, therefore UPV on stage. Thank you very much. 10 minutes for each presentation. Be on time, we are starting slightly late, but that's okay. Thank you. In case he was asking questions from the audience about the demonstrators, if we are on time within the 10 minutes, because you finished a couple of minutes earlier, we will open it maybe for a question or two. But otherwise, we have the 2 hours afterwards where we can interact. So let's go like that, maximum 10 minutes overall. Thanks.
Okay, thank you, Michel. Well, good morning. I think we are everyone here, despite the limoncellos last night, so that's great. I'm going to present the Valencia demonstrator, which is focused on draft and heat waves. And I will start just with the city of Valencia, which is by size the third city in Spain after Madrid and Barcelona, with around 1.5 million citizens in the metropolitan area. We have a Mediterranean climate, similar to Sorrento in temperatures, but not in precipitation. I was looking at the data this morning after looking at the window, and it results that in Sorrento it rains double the times than in Valencia, so that explains this weather. Water then is scarce in Valencia, and it has to be carefully managed by the basin regulator in the region. Regarding temperature, the average temperatures in summer is about 31 degrees. Here in the graph, this is from this year, actually. And you can see peaks from around 40 degrees in the city. That, combined with the high humidity in the city, creates a lot of climate discomfort. So heat waves are increasing the thermal discomfort in the region and also the energy use during the summer. This is also the case because the city buildings are not well prepared for these situations, for these thermal conditions. And drought is also affecting the ecosystems near the city. Here in the picture, you can see the Albufera, which is a natural lagoon south of the city of Valencia. I think if we are going to go to Valencia in the following meetings, we may visit the Albufera lagoon. Regarding water, you can see here how the distribution is between the different users. Agriculture is the main user in the basin and also in the region, with urban about 10% of the use of water. This is important even for the city of Valencia because surrounding the city of Valencia, we have the Horta of Valencia, La Huerta de Valencia, or the orchard of Valencia, which is a very special environment where we have the typical lemon and orange trees, vegetables, and so on. Recently, in 2019, it was recognized by the Food and Agricultural Organization as one of the globally important agricultural heritage systems. And this is something that we have to put in value. I think, just talking with some people yesterday, the consortium is very varied, and maybe you can help us with this to put in perspective the importance of the Valencian orchard, because with the FAO, with the Food and Agriculture Organization, we don't only get this recognition, but it's also a commitment. We have to make sure that this heritage, cultural heritage, is evolving with the city, and it's changing within the realms of the city, respecting its reality, its cultural heritage. We have constructions and canals that date back to the Romans and the Muslim occupation later. Also, we have the Tribunal of Las Aguas, the Water Tribunal. That is an institution. It's the oldest institution in Europe, the oldest tribunal in Europe. They still meet every Thursday in the cathedral. Nowadays, it's just a tourist attraction, I guess. But back in the day, it was very important to set the disputes and the agreements between the water users of this Valencian orchard. So this is about the city, and now about our work in the region. First, I will talk about drafts. And this is a study that Roting knows very well, because it was done in the Innova project, where we developed this model for the whole basin, the HuT River Basin, which is responsible of supplying 2/3 of the water resources to the city of Valencia. We simulated this model with 3 main reservoirs, Alcorn, Contreras, and Tous, with the first or more important agricultural uses and the stream aquifer interactions, between other things. The objective was to represent the real management of the model. So we put a lot of effort into representing the operating rules of the reservoirs to mimic the real operation of the system. And there in the graphics, you can see the comparison between the simulated results and the historical records. And we think that the results are good enough to use this model for simulating scenarios. So now that the model is representing more or less the reality, we can input some, for instance, climate change scenarios. We did that and introduced 11 combinations of climate, of regional and global climate models, climate projections, sorry, for the 4.1 and 8.1 scenarios, the most optimistic and one very pessimistic scenarios. And we see the results for the Tous reservoir, which is the reservoir where the water that is supplied to Valencia origins. In orange, you see the results for the control period, so the model running the data from that period, from the 70s to the 2000. And in different shades of green and blue, you can see the results for the different climate scenarios. So we see a reduction of between 27 to 60%, depending on the season. And this is important, maybe not because this is going to put at risk the supply to the city of Valencia, but because it will have an impact on the water quality of the region. That's some previous studies. I don't want to go into much detail because I think we will do that later. So now, what can we do in the HuT? Well, first, we need to raise climate change awareness in the city and in the surroundings. We need tools for monitoring water quality in this reservoir and in the basin. And with this, we could develop early warning systems. We are collaborating with one of the stakeholders of the project is the water utility company of Valencia, and they are very interested in developing this kind of systems. They are also interested in designing new pathways towards this future climate scenario. So how they can adapt the current water treatment plants for the new scenarios. This is regarding water, no, draft. And now we're going to heat waves. In previous studies, we have seen that the frequency and the intensity of heat waves is increasing due to climate change. In some of the projections, the more pessimistic ones for 2070, we see a rise of 2 degrees in the city, which would be catastrophic for different sectors, such as the agricultural sector, because of the increase of water demand. And in the more optimistic scenario is a 0.1 rise of temperature. This will also affect the climate discomfort of the citizens of Valencia, and it will increase the energy use in the summer. And also related maybe to some of the comments that we had yesterday from the Helsinki colleagues, this will affect differently depending on the income of the neighborhoods within the city because of the type of construction or the type of materials that they use to construct these buildings. In previous studies for heat waves, we have developed this digital twin for one of the neighborhoods of the city, Benicalap. We have collected data for thermal storage and urban heat emission, and this is critical to design this new city towards the goal of carbon neutrality towards 2030. So if we want to reach that, we want to make sure that the buildings are adapted to the new climate situation. What can we do in the HuT? Well, that's why we are here, and we want to talk with you because we want to see where we can synergize. No? For a starter, we can develop a pilot in the UPV. That would be a small pilot, but that would allow us to develop a very precise digital twin, to install different sensors and to monitor temperature, and to see how to integrate new materials in this type of building with the expectation of going further and translating this to the city of Valencia. That is my presentation. Some contacts from me and my colleagues, and I think we have 10 seconds, so I don't know if I have a very quick question or not. Thank you very much.
I would move to next presentation, Marcel, UPC.
Okay, thanks. We stay in Spain. We go to the Pyrenees, the Vall d'Aran. It's demonstration 2, and UPC is the leader, but the group of Arantec here also is located at the end inside the demonstrator area and will also participate. You can start the clock. Somebody? Oh, I have to start the clock. The clock is now it's started. Yeah. Okay. So where we are now a bit north of Valencia. We are here. Oops. Yeah, in Catalonia. Barcelona is here down. UPC is here. Arantec is located here in Vall d'Aran, and this is more or less the area that we cover. in the Central Pyrenees. It's a typical high mountain area, more than 600 square kilometer, and the climate is affected by Mediterranean factors, also by Atlantic, because it's part of the north-facing Pyrenees, so it's coming also the effect from the Atlantic winds. And the process that we are dealing with are typical high mountain processes, floods, flash floods, torrential floods on one side, and then we have shallow slides, debris flows, large landslides, and so we have this, what was mentioned also yesterday, this multi-hazard aspect and this especially cascading effects that landslides can produce sediment that afterwards transform in torrential floods and affecting downstream the area. Exactly that, what I mentioned now, this cascading effect occurred in 2013. This was a quite exceptional flood, and Morle means multiple occurrence of regional landslide events. So we had that in June 18. It was a combination with snow melt, 2-3 days of rainstorms, and yeah, yesterday we already saw some impacting videos from Arantec. It was in the valley floor a lot of damage and total loss of more than 100 million euros. Okay, so this is a bit our episode that we can use to calibrate our models and apply our models, verify. So the institutional setting in Weideran, we are the leaders from UPC, close together with Arantec, and then we have the regional administration is Conseil General d'Aran. It's it's dealing with the Weideran Valley. Then we have Pompier MR. This is a combination between fire workers and civil protection. You can see they have just got a new control center that we visited last summer, that you can see on the photo. And we are also in contact with the Institute Cartographic and Geologic of Catalonia, that you will see soon that we have some collaboration. So this is a bit the institutional setting. And what we have done until now. We have on one side this Catalan-wide, it's not Weideran, it's from the whole Catalonia landslide early warning system. That is a collaboration that we have with the Institute Cartographic and Geologic of Catalonia. It's until now a prototype, and we try to test it now during this year until next summer, and to improve it, and in the future we hope that it will be operational. This deals with landslides and debris flows. On the other side, Echark from Arantec already explained that we have Smarty River along the main river, the Garona River. Then we have also Smarty Meteor, Smarty Snow, monitoring that deals in the area of Weideran. And then we have, from a more research point of view, we have other instrumental monitoring of debris flow catchment, landslides, and other processes. What we have done until now, we have dedicated quite a lot of work analyzing this 2013 event. We had also a large landslide that occurred 2018, that more together with our geotechnical engineers, this material point method that is now the most innovative modeling for landslide failure and also run out. We did that. We have from our monitoring side, we have the analysis of debris flows and debris floods from local scale. This is in one catchment. Then we did also landslide susceptibility assessment in Weideran, and there we got quite interesting results about the impact of future changes. We not only looked the climate or the rainfall changes, we also the land use and land cover. And surprisingly, in our area, the effect of land use, land cover, due to the abandonment of agriculture. So the forest was increasing, forest area was increasing. So this was more important than the higher intensity, frequency of the rainstorm. So this was quite surprising, and could be interesting to discuss that. Perhaps we have to focus also even more on land use, land cover change than on the climate models. So, but this is also only focused on Weideran. If you go to another site, could be totally different. So, and we also did some landslide risk assessment, and we tried to do a GIS toolbox for that. Only to show a bit after all these letters, what we have done with this Catalan early warning system about landslide and debris flows. We have on one side the susceptibility map, and then we have the rainfall that we cover with the weather radars that we have. The problem is that Weideran is inside Central Pyrenees, and there the radar is not is arriving, but not as good with as good quality as in other location. But the methodology is like that: susceptibility, weather, rainfall radar. Then we have rainfall threshold criteria, and with that we go to the warning matrix, and at the end we have this every half an hour we have this warning map. This is what we now are testing with the administration over whole Catalonia, and sure we can get good information, or we can use this information for our site in Weideran. And on the other side, only quickly that we have in what we have installed with Arantec Smart River, we have these sensors at many bridges, 10 or 15 bridges in Weideran area, measuring the flow depth. And we have also meteorological information that we can visualize and make warning levels, as you can see on the bottom right. Okay, and then more from a research point of view, but we can use this results from our monitoring catchment, where we have a lot of sensors, and we have more than 10 years of data. We try to make this approach from a local scale to regional scale, especially with thresholds that we define from rainfall, from soil moisture, to deal with these torrential flows, flash floods, debris flows, debris floods. And we have wired system, wireless system, and also we cover all the area by an annual drone flight. Okay, so I have one minute. Here is the list that is in the proposal. It's quite long. We have this list of tasks that are written in the proposal. Until now, in the bracket, you can see that I have put where we can cover Arantec or UPC, the tasks. There are many locations, there are 3 dots. That means that we would like to, afterwards in the speed dating, that you can help us to cover the parts that we are not really experts, especially the human economic aspect, also the meteorological, if there are meteorological experts. I saw yesterday some nice approaches that we can, or we hope that we have this collaboration. This would be nice that during the speed data you can explain us your experience. And at the end, only very fast, at the end the global results from us would be this impact-based early warning system for landslides and floods. We have some kind of prototypes, and to go a step further, we make it operational. always thinking about this impact base, so we need the risk assessment. We want also to include these cascading effects. Communication, once again, we are not really experts. We know our stakeholders, but communication is a bit complicated. Scales problems, and also, once again, we have normally real-time monitoring, but yeah, for an early warning system, would be very useful to have this nowcast or forecast. So, thanks. This was too late, too much time, but yeah, we can discuss it afterwards.
Yep. Thank you very much. And then, yeah, you can. I don't want to stop the applause. We move to them three. So now we are here in this area.
Okay, good morning. Now I would like to provide brief details about Demonstrator 3. Formally, CMCC work will as a demonstrator leader, but all the activities will be agreed and carried out with the University of Salerno. With the label Lattari Mountains, we consider a quite large area, 300 square kilometers, with a population of about 450,000 inhabitants, including 32 municipalities. Very different for natural heritage, artistic value, wealth, socioeconomic features, also taking into account the population from Furore and Atrani with about 1,000 inhabitants up to Castellammare di Stabia with 75,000 inhabitants. The area is globally recognized for its artistic value and cultural heritage. Amalfi Coast is enlisted in the UNESCO World Heritage List, and at the same time, also the art of dry stone walling is described in the representative list of intangible cultural heritage of humanity. So under such perspective, the touristic vocation is quite high in the area. We have, in this case, more or less 1 million of foreign tourists per year, 4 million overnight stays, and an income of about $500 million. So, all the towns are more or less crossed by the Lattari Mountains chains, and they imprint more or less the hydrological and natural hazard experienced by such towns. For example, landslides, they affect the pyroclastic covers mantling the carbonate bedrock, and they are especially experienced during the final part of the wet season. On the other side, we have a lot of small mountain basins. They are vulnerable to flash flood induced by heavy rainfall of short duration. Also in this case, the abandonment of loss-making agricultural practice induced an increase in hydrological hazard, and also during the hot, dry season, the increase in fires. Fires have a double role, okay, because they are an hazard per se, but also should be considered as a predisposing factor for the hydrological hazard. In the recent years, the area has experienced an increasing number of severe storms that can affect assets, crops, communities, especially when they occur outside the wet season. Since the beginning, we have considered our main stakeholders, the municipalities. Why? Because they are, for the Italian government, in charge of the civil protection. They issue the municipal civil protection plan, and they are in charge of land use planning. They issue the municipal development plan. So they put together all the time horizon covered by the HuT. Not by chance, we have already fixed a sort of kickoff meeting for the demonstrator activities for November 3, again in Sorrento. Furthermore, the municipality of Sorrento, as said before, is a partner, an effective partner of the HuT, and we act as a lead municipality for creation of a local DRR Nexus Forum. But they are not the only stakeholders. We have some supra-municipal authorities, for example, Multi-Risk Functional Center for Civil Protection, the Authority of the District Basin of Southern Apennines, Monti Lattari Mountain Community, Infrastructure Managers, Consortia for the Promotion of the Territories, Professional Association. We have in this area a lot of NGO working also to protect cultural heritage, natural and environmental landscape and so on, but we cannot not considering tourists because they are usually not aware about the risk in the area, and they don't typically understand the message or signal meaning during the active stage of the emergency. Okay, about the innovation already in place, we have to say that we are not scratching from the ground, but we have not a large suite of innovation already developed. Of course, we have fully operational in the region a alert system for precipitation-induced events. They are based on weather forecast and rain gauge networks. The thresholds are fixed for different time horizons according to dynamics, and the exceedance is checked to give alert, pre-alarm, and alarm. But the thresholds are not physically based, so tailored for the different dynamics, but only based on return period of the precipitation events. So after this information is transmitted to municipality, and they should follow the procedures reported in their municipal emergency plans. Okay, what we have again in place in some towns near the demonstrator area, in the Cerno area, there were in 1998 different landslides events that entailing a large number of victims, about 160. So after these events, there was an increasing effort to increase the comprehension, the understanding about the physical reasons for which these events can occur, and so there were some experiences of field monitoring, but I would say that they are quite sparse in time and space. The area was also test case in previous project where also other partners of the HuT were involved. For example, for Safeland, where a participatory process related to mitigation work had been carried out, or for Intact, where an assessment about the landslides risk suffered by critical infrastructure has been carried out. Okay, these are the list for our demonstrator about the activity that should be carried out in the demonstrator. It is probably driven by the wave of the enthusiasm during the drafting of proposal, because as you can see, there are a lot of activity listed. In red, we have reported those more or less common to all the demonstrators, but the ambition here is, for example, to have a data portal linking different stakeholders joining the local DRNX forum, acting as support for early warning system or land use planning, developing a testing standardized procedure to evaluate the effectiveness of a warning system. But on the other side, we would exploit also the expertise of CMCC for an update of planning operational tool in a climate change perspective, also take into account the other forcing before Marcel cited the role of variation in land use. So this is more or less a first list. We have the occasion during the innovation stage to deepen out all these aspects, hopefully. So if now check the list of expected results as reported in the canvas of the project, more or less the expectations are that in the demonstrators 3 we can deliver, that we can achieve all the expected results should be achieved. Okay, this is our ambition. We work for this one. So, but now we can focus our attention on the outcomes, what is expected at the end of the project. The idea is downscale the HuT Nexus approach at DEM3 scale, because during the project we have different innovation that could be tested at pilot scale, not all the innovation in all the places. But it will be crucial to ensure a full transferability, replicability, and confident exploitation beyond the project. So the ambition is to move to the white and blue condition at the end of the project. Okay, on long-term horizon, we can move behind the borders of the demonstrator 3 and try to transfer, replicate the most important, the most interesting innovation in the largest context of a Campania region. On the other side, it is very important for us to ensure that innovation platform, local DRR Nexus Forum, and the platform per se, could maintain themselves fully operating, because in many cases, when a project ends, all the innovation, all the activities linked to the project end in the area. So it is important to permit that all these activities can be fully operating after the end of the project. We would like to use this project to promote a consolidating a cultural risk in the region. For example, today, as recalled yesterday by Karina, it is the International DRR Day, but a very limited number of initiatives was organized in the area. So we would like to use this project also to consolidate a cultural risk, for example, for annual events linked to the HuT, linked to the International DRR Day. But in this perspective, it is important to consider that for the area, for the region, we should probably take into account also other dynamics and natural hazards very important, very significant for region, for example, volcanic and earthquake risk. This is more or less the presentation. Thank you.
Thank you very much, Guido. And then them four now, Vilnius.
Good morning. I will present much less problem than Guido showed now, because, you know, area is much smaller, and as told yesterday, Vilnius is located at the edge of European Union. It has about 600,000 inhabitants, and Old Town is included to the heritage site of UNESCO. And the main problem I would like to talk, it's fluvial urban flash floods. Why it is important? Because it's become more and more frequent. For example, 30 years ago, it happened maybe once per year, maybe once per few years, and now it's 2 to 8 times per season. So it absolutely stops traffic for few hours up to 1 day, and no private and public transport can go through streets, and we have traffic jams and related problems. The main factor affecting such flash floods are heavy rains, and origin of such heavy rains are also different. It could be mesoscale system, convective system, it could be frontal substructures, it could be central part of cyclones, but more often it is hybrid. It means both frontal system, then a central part of cyclone, and then mesoscale convective system, including squall lines. And this phenomena can happen from May to September. It means warm season. And why it is so actual now? Probably because urban area expanding so fast, too many artificial surfaces, pavements, and rainwater collects too fast. Also, new street structure now is almost everywhere is new designed, but layers underground seems to be old from Soviet times or even from earlier times, and water collection systems are unable to collect such intensive rainfall. The key stakeholders you see here are three. Lithuanian Weather Service is a user-friendly organization. It provides data and warnings, and also municipality. Communication with municipality always depend on political situation, probably you know, in every country. And also the joint stock company Grinda, which is completely 100% is municipal. Their webpage states their activities here, and from the one hand, it's a main actor in our project, but from other hand, it has no competition with other private companies in the city, because all orders comes from municipality. So it's difficult to communicate. What we have in observations site, two official stations in the area of city, but outside the central part. Few unofficial stations, one in the yard of university campus, you see here. Also weather radar, which is 15 kilometers away from Vilnius, but works not always properly with interruptions and with noise in signal. And you see here an example of coming rain with some substructural patterns. During project, together with Lithuanian Weather Service, we are planning to install 6 new rain gauges inside central part of the city. And it would be enough to, let's say, to have a complete picture of distribution of heavy rainfall inside the city. What are our experience and what we can do during this project? First of all, probably we should assess the heavy precipitation events and for the present climate situation in all synoptic flow conditions. Also to downscale climate scenarios for such weather events for our region, and also use weather generators as alternative source, and other tools. What we can expect from other groups, from other institutions, I don't exactly know at the moment. Probably there could be some approaches for nowcasting, for warning system, updating warning system, maybe to use some green infrastructure techniques like this one, which is already used in our city. Instead of shaving grass around the roads, they left them without cutting. They think that it helps for dry periods and also stops slopes. Sorry. and stops fast flash flood going from artificial pavement. And also, we are open for suggestions, questions, ideas. All these pictures are from this season.
Thank you very much. Now we have DEM 5. We go to Germany. From what I understood, Yeah, she prefers to use. Dico anche che sta per usare il microfono wireless, si mette al centro del
Thank you, Michele, for letting me stealing your microphone. So, because I prefer to stand in front of my own presentation, and right now I'm putting on the hat of a demonstrator. I have different roles today, and I'm representing the demonstrator is because before the project got approved, I was already engaged them for integrating disaster reduction and climate adaptation activities. So I will talk about it. So what is our demonstrator? So if you see the name, it's a state, Schleswig-Holstein. Why is it state? We actually are going to engage different levels of the stakeholders. So we are going to engage the municipality, but our actual goals are actually citizens. And the citizens of whom is the rural town. So if you look at the coastline of the state, Schleswig-Holstein, the North Sea coast, they are actually under the sea level. So if you visit some of the town in the municipality, their name, they just call themselves, we are Westermarsch, our city is under the sea level. That is part of their slogan, part of their municipality name. And you can see that how they already perceive their own risk, and these are the rural towns we're going to approach. Why it's really important is because before the HuT project, they are never the winner cities. So whenever the research project or whenever there's a demonstrator project, these rural towns who have the democratic change that 30 to 40% of their citizens are above 65 years old. Young people are moving out, only the old people are staying in a small town, the job opportunity are shrinking, the economy are shrinking, they are struggling with their survival. So the projects never reached them. So when I first approached these rural towns, their eyes were wide open, said, what? HuT, you are willing to work with us? And if you visit their urban planning department, they have one person who is either 2 years away from their retirement. So if you talk about future perspective, they don't know what to do. So if you come with 3 different projects, early warning disaster reduction, SDG project, climate adaptation project, it will all landed in one person, in one municipality. And this is a reality of the rural towns in the state. They have different kind of disasters. So the first type of disaster are this hydrological disaster, like water everywhere. They have the water from sea level rise, they have the fluvia and pluvia flooding, and this kind of typical flooding, and then they create a cascading risk. And they also, at the same time, there's an increasing research showing that those areas, when they have the higher moisture level and when the temperature is increasing, actually have the higher influence on the health. And remember, they are about 30 to 40% of the aging population there, so they actually have higher impact on their health issue. And this is the growing trend that we should also watch. But the cascading risk is not only because of these extreme events, but also it depends on local capacity. When a climate extreme hitting a town with a huge capacity, they are able to cope with it. But if you land those disasters landed on a municipality, they only have one person responsible for the unit, then they will have more damages. So this kind of limited capacity in the local level, the social-economic risks that they're already struggling with the economic development, they only have the voluntary first responders, they don't have the professional one, and these create more disaster there. So even though we are the scientific leads, but we actually engage the municipality and different kind of level, the boards of the citizen. How we are going to do it is that we engage the municipality directly, but how do we reach citizens? If you see the coastline, there are so many rural towns, there are so many citizens. So we decide to engage the so-called knowledge broker. We want to reach as many citizens as possible. So we identify at least three levels of the knowledge broker. The first one, they are professional companies and NGOs, they are doing citizen dialogue. So most of the towns that I told you, even though they don't have capacity for climate research, for disaster warning, but whenever they are building a playground, they do citizen engagement. They invite the whole community that the kids pick the playground that they want to do. So they do every mini task, they do citizen engagement. They are the expert of citizen engagement. So we only need to come, the HuT, we only need to come with our expertise. They know how to distribute it. They know how to engage at a local level. So we are going to engage those citizen dialogue facilitators, like the local companies, the district board. So each of the city quarter, they have their own, they call it Stadtbeirat. So it's like a local district advisory board. They consist of the citizens. And then yesterday you hear from the useful experiences using the art and culture also as a narrative approach. So we are going to engage these kind of local culture and art knowledge broker to reach to more citizens. And the third level is the media. So so far we successfully engaged one really huge German media called Die Zeit. So they will work with us how to come out with the right visualizations, how to use the science-based information, but be able to publish on the newspaper so the locals can actually understand what to do. And if you ask me what would be the key innovations at the local level, I have to be honest with you, no. So there are different kind of existing activities or apps developed, but what happens when it comes to the local level? So for example, the national level in Germany, there are at least 2 to 3 apps. Katwa, Nina, they have these kind of apps. But when you live locally in those rural towns, there are 2 situations happens. Is that if the flooding is expected to come, the river is, sea level is rising, then you will get a warning 8 times a day, 3 days in a row. What do people do? They switch off their phone. They delete the app. Because the early warning send out too many warnings without telling what would actually happen, without telling what actually they should do. And the second thing is, there's even the criticism that sometimes the locals, they only receive the warning 2 hours after the flooding happened. So at the local level, people don't rely on the early warning app, sadly. And then at the state level, if you look at the Schleswig-Holstein state adaptation plan, this is a plan they tell you that this is what we are doing in Schleswig-Holstein. So you see, they are really heavily relying on building dikes. But in the North Sea coastline, these dikes have been 20 years old, not renewed because they struggle with a budget problem. So they are merely maintaining them, but they are not able to renew them. And at the local level, there are some single events. So for example, first responders, they are starting to ask what would be the climate information, the future climate risk for them. So if you are building a new quarter, they engage the citizens, and the citizens say, we want this quarter to be net zero, to be sustainable, and to consider the future climate. So they have this kind of concept, and local people ask for it, but they don't have this kind of systemic input like the HuT project. They can have the scientific input going into the local level. So then what kind of innovation we want to do in this demonstrator is that in Garrix, we already have these climate fact sheet available for every township in Germany. It's open access, everyone can click on it where you are living in Germany, and you have these climate projections until end of the century, and a different kind of climate risk. It's open, but you know, these are numbers. So if I go to citizens, they wouldn't understand what numbers mean. I spent 2 days in a workshop to tell them what's the RCPs. This is the reality. So what we are going to do is that in this demonstrator, we are going to take one step further, is that these are the best available climate information in Germany. So we are going to do is we are going to develop with the stakeholders to develop into a narrative-based climate information. So we are not giving them fact sheets or 4 pages with number. We are coming with them to tell them, from your perspective, what kind of climate risk you think would be concerning you. We pick those climate risks. So when they receive this kind of climate information, they will first see themselves as first page. I'm 60 years old. I'm not so mobile because of my health problem. I'm worried about these climate risks. I live here, so here is my climate risk in 2050. So they see themselves at the first page. So they immediately know what these climate risks meaning to you without understanding what the numbers behind RCPs. So this is what we are going to do. And then we are going to work with the knowledge workers. And how we are going to do it is that with this process of co-development, we don't want that we develop something and at the end, they don't use it. So if we co-develop this kind of narrative fact sheet with them, then at the end, they also feel part of the ownership, they will want to use them, and they know the process, they know their stories are inside these kind of climate information. And these kind of climate information is completely designed for them from the user perspective. And then we work with a knowledge broker from cultural art point of view, from the media to hopefully to accelerate the uptake. So right now I'm talking about 1 or 2 municipalities, but I really hope through this knowledge worker at the end of the project, we will reach as many municipalities and as many citizens as possible. So this is what we promised here, I said before, what we promised, or let's say what is written in our proposal. And then I hope through the speed dating later on, we can get a lot of more input from you. What you think you can contribute to a rural towns in the sea level rise prone area, then you can come to us and then we will put you in this after column, say, okay, this is what we are going to collaborate in the next 4 years. And then we might even get some new ideas. So from yesterday's useful experience, we got some really nice input. So we are going to develop new one, like the narrative-based approach with a knowledge worker or this media co-design, co-development, or more that you can propose. We will also be happy to add on to our work. So what will be the vision for our demonstrator at the end of the HuT project is, as I told you, if you go to the local level, they don't have so much capacity. So I really hope at the end, all these kind of services we offer them are integrating climate adaptation, mitigation, SDG, as well as the disaster reduction. Should be all-in-one integrated services, and that's our view. And I hope to interact with you during the speed dating. Thank you.
Thank you very much, Joting. So next in line, DEM 6, Iceland.
Good morning, everyone. I will be introducing the demonstrator in Iceland, which is the East Fjords of Iceland. And especially we are looking at 2 towns, Seyðisfjörður and Neskaupstaður. The East Fjords are a beautiful area with narrow fjords, mountains that are 500 to 1,000 meters above sea level. Many of the fjords have small villages or towns, and many of them are prone to landslides, slush flows, and snow avalanches, which have caused many fatalities in the past and extensive material damages. So in Seyðisfjörður in 1885, there were 24 people killed in their houses by an avalanche. In 1950, there were 5 people killed in a house by a landslide. And in 2020, we had big landslides in Seyðisfjörður, but fortunately, no lives were lost, partly because of most of the houses had been evacuated prior to the event. In Neskaupstaður, the biggest accident was a snow avalanche in 1974 that took the lives of 12 people. The institutional setting in the demonstrator area, we are 3 partners who will form this team, and we think it's a good team that we have, because we have the Icelandic Met Office, who is responsible for monitoring, hazard mapping, and approving mitigation, permanent mitigation in the area. We have the Department of Civil Protection and Emergency Management, which is responsible for daily administration of civil protection matters. And then we have Austurbrú, who is like an umbrella for all the municipalities in the area. And they will represent the municipalities and inhabitants of the area in this project. But general stakeholders are the inhabitants, of course, municipalities, the companies in the area, local civil protection actors, and other decision makers. The key tools that are already in place, we have avalanche and landslide hazard maps for towns and villages, including Seyðisfjörður and Neskaupstaður, but of course such maps are never final. They always need to be improved with some years And those hazard maps are the basis for both monitoring and mitigation in the area. We have evacuation maps and evacuation plans for towns and villages, including Seyðisfjörður and Neskaupstaður. And in Iceland, if a municipality has a red zone in the hazard map for a town or village, they are required to take permanent actions. They can either choose to relocate the settlement, or they have to install permanent mitigation. There is a national avalanche fund that pays for 90% of the cost, and mitigation measures such as avalanche walls, supporting structures, breaking mounts, as well as slush flow and mud flow defense structures and stream channels have been built in towns and villages in the East Fjords. But there are still many areas that are not protected yet. We have at IMO, at the Met Office, we have avalanche and landslide forecasters who monitor the danger on a daily basis, both regionally as well as locally. This monitoring is based on avalanche and landslide history, hazard maps, weather observation, weather forecasts, data from specialized instruments we have in place, and on-site observation, which is also very important. Towns and villages with considerable avalanche and landslide risk have snow observers that are hired by the Met Office, and they gather data and observation, and they advise the forecasters regarding avalanche and landslide danger, but it's the forecaster who make the decisions. And this is a very important system for us because instruments and measurements can only tell us so much, but having a system of local observers is very important. And then we have instruments that have been installed for monitoring purposes. We have automatic weather stations, mostly on the lowland, but we have automatic snow depth measurements in the mountains. And then we have been installing during the last 2 years after the landslides in Seyðisfjörður in 2020, we've been installing instruments that are specially for landslide risk monitoring. Automatic GPS stations, automatic total station, INSAR ground-based radar, water level gauges in boreholes, shape arrays in boreholes, extensiometers, thermistors for surface temperature, and so on. And then we are installing a weather radar in a new area, in a new place, which will be especially good for this demonstrator, the East Fjords. And then we also have other types of tools, like demographic statistics for the area held by Österbro, our partner. And they have conducted a research on social resilience in the aftermath of natural disasters for Seyðisfjörður after a landslide in 2020. And they did that by interviews and questionnaires. And there is experience and system of running mass relief centers during periods of disasters or high danger. And there's also experience and system on carrying out evacuation during periods of high danger. For example, last year, a sign like this was sent to every house in Seyðisfjörður with instruction on how you evacuate your home, and people are asked to put this sign in the window when they have evacuated so that the police knows that this house has been evacuated. Just a few pictures. Top left is Seyðisfjörður after the landslides in 2020, where many houses were destroyed. Top right, in Neskaupstaður, 1974, where a snow avalanche killed 12 people in the town. Lower left is an example of an avalanche catching dam in Neskaupstaður. Those dams are huge structures, 15, 17 meters high, and vertical on the side that faces the mountain. And then we have a picture of an instrument in Seyðisfjörður, part of our system there. So what we hope to do within this project is to develop better precipitation forecasts in the area. It is a challenge to forecast precipitation in complicated landscape like fjords and mountains. And we want to analyze data from the new installed weather radar and also weather models and measurements. And we want to improve our avalanche and landslide forecasting and monitoring based on better precipitation forecasts, but also we want to improve the setup of data for our forecasters And we want to define, we want to improve the definition of meteorological threshold values for forecasters. And we also want to create or develop improved methods of comparing current or forecasted weather to past weather events. And we also want to develop a platform for inhabitants because we feel that our challenge is to get information to people living in those towns. And we want to develop a platform that would be hosted by the Department of Civil Protection and Emergency Management, where we can share information both from the police, from the Met Office, from the municipalities, but also with the possibilities of inhabitants to share information back if they see something abnormal or just want to share some stories. This platform would focus on natural hazards, but it would be possible to add other types of hazards, such as diseases or accidents or anything like that. We want to share real-time information on the situation during periods of high risk, but we also want to have easy access to existing hazard maps, evacuation plans, technical reports, etc., and easy access to informational support, such as financial compensation in case of a disaster, psychosocial support, and so on. And we want to have educational material in place, and we want to create this material within this project. The challenge in modern society in Iceland is that in the old days, people used to live in one town their whole life, and they learned about natural hazards from their parents and from their grandparents. But nowadays, people are much more mobile, and in those towns, there are people who come from different parts of the world, and they have no knowledge whatsoever of snow avalanches or landslides. And also, modern parents, they expect the schools to educate their children. So we want to use technology to kind of raise the awareness of natural hazards. Luckily, those big events, catastrophic events, are rare, but that also means that people tend to forget about them when there are a few years since the last event. This is just a list of innovation to be carried out in the demonstrator. And we hope that after the HuT project, we will have better precipitation forecast, improved monitoring, and a functional platform for sharing information that we can also use for many other towns and villages in Iceland. Thank you.
Thank you very much. I have now DEM7 Kotivizig.
Good morning. So yesterday I introduced myself. This is the map of our water direction. There are 12 water directions in Hungary. And you can see with different colors, different water direction. And our, the Kotivizig, the middle district direct water direction, is situated 7 counties, not countries, a mistake in my presentation. So it's our territory area is 7,200 square kilometers. In our territory have some hazards, flat, flavial and pluvial, also and drought, heavy rain. But in this project, in the HuT, we focused on floods, mainly the pluvial floods, and maybe the heavy rain effects. But the general activities of our company, the flood management, river regulation, irrigation system maintenance, water quality control, environmental damage control, groundwater management, drought management, and nowadays the water collection is also a problem, and we take part some international project also. Yes. Here you can see in urban area in Hungary, the municipality is responsible for the protection against the pluvial flood, and the rural area, the water directorates responsible. But we have some tasks in urban area also. So it's our responsibility to preparedness. Our main stakeholders, the municipalities. In our territory are more than 100 municipalities, the Hungarian Chamber of Engineers, the planners, other water directorates in Hungary, and the technical experts who taking part in the protection at pluvial and fluvial flood situations. So yesterday I speak about the HuT or Water 24 application. It's not just a forecast system, then this application support the protections because contains every important informations, data. The municipalities have water defense plans, and it contains the applications also. Yes, it is made in 2019, but last year was a development, upgrade, and our aim to development because there are some general problems with not the application but the whole system, and we would like to solve it. But first of all, we have to find the appropriate way. So first of all, we will the stakeholders informants for know the demands, and we would like to develop the warning systems in the application, and the new innovation is a new method how to make the water defense plans in Hungary, because at the moment it is in paper form, but in the future we would like to in real digital form do it, and we would like to develop of Water 24 or HuT application fit to the new method, the water defense plans. And I don't know who make this list, but I think we can use it for our activities, because I write some tasks in main points. So first, the involvement stakeholders, it's very important for the first steps. And we are the demonstrators in 7, so I think we have to share our knowledge, our experience about the application and other things. And I don't know what does it mean exactly, the demonstrator data portal, but we learn it. And we search the appropriate warning system for application. And its application is a decision-making because not just warning system, but the people who take part in the protection can bring the appropriate decision by application. So I think it's absolutely transferable, but have to adapt to different conditions of countries. We will take part or organize some data nexus forum, and we will examine the transferability and scalability of the application. And here are some questions, because the last is in the VP6, but we are not involved in VP6, so I don't know that we have to do realities tasks. It's in future we speak about it. And our vision, we would like to new method of making defense plans, and in harmonizing with this activity, we would like to develop the Water 24 application. And we hope that in the future, in our territory, the planners start to use the new method for the water defense planning process. And at the moment, the application is, we are real work it, but we hope the municipalities will use the upgraded applications. And we would like to extend the application for Hungary. And the impact, the damage of pluvial flood and heavy rain events in urban area will decrease in future. Grazie, thank you.
Oh, yeah, thank you very much for the presentation. Then Ogliastra now, CMCC.
Good morning, everybody. The demonstration number 8, located in Ogliastra, is formally led by CMCC, but also CNR will work on this. So we will share together with my colleague Costantino this responsibility. Okay, so here is the Ogliastra region. It is in Sardinia Island, so we have a surface of 1,800 more or less kilometers square. This is one of the most forest area in Sardinia, about the 42% of the surface. But on the other hand, it is one of the less habited region, because we have more or less 58,000 people. But this number increased about 10 times in summertime. So because the tourism. The hazard that we are going to tackle here are the hot ones, so droughts, heat wave, and fire. And actually, in one of the last biggest fire that we had there, occurred in 2019, where a fire, the Orri fire, burned about 800 hectares in a well-run urban interface area. Fire is one of the biggest problems here, also because the typical Mediterranean maquis, the summer situation with a lot of tourists that are not familiar at all with this type of risk, because they came from northern part of Europe mostly. So I listed the organization owing them 8, but also there are other institutions participating in this demonstrator. First of all, Confagricoltura. You met Francesca yesterday. And we also hope to work with IASA and LETA. Here we listed the main stakeholders that we already identify in the area. They are not listed in order of importance. So we have Confagricoltura for sure, and all the farmers that are under the hat of Confagricoltura. l'EITA, the forest rangers, so because there are different forest institutions in Sardinia that are, because Sardinia is an autonomous region, so we have a number of institutions dealing with firefighting, forest management, and civil protection. Then a local municipality, meaning the local government, but also the community, the citizen association, the volunteer association dealing and working together, the civil protection, and also the touristic facilities that we have there. Guido asked us to illustrate the key innovation. Well, I don't know if I can say they are innovation. Mainly in Sardinia Island, so also in Ogliastra, we have a national and regional plan for coordinating the forecast, prevention, and firefighting activity, which is reviewed and approved every year, more or less in April. Under this, within this plan, we have a number of information concerning a territorial level, so including the Ogliastra province. We have information about the human instrumental resources, the lookout, the water resources for firefighting. Then we have also the municipality plan and the municipality fire danger risk index that should help the municipality to cope with this risk. Sardinia civil protection issue every day in summertime the meteorological forecast and the fire danger forecast bulletin. And this bulletin is, can you see the pointer? No. Okay. Anyway, is this one? On your left. Sardinia is divided in region, and there are different colors that illustrate the type of risk. Clearly, the red one is the most important. And there are also a number of protocols for fire suppression, but also evacuation for citizens, tourists, farmers, and so on. So all these information are used for forecast, prevention, and firefighting activity mainly. But I have to say that prevention is minimally implemented. So prevention is something that we wanted to tackle in this demonstrator. And our aim is to provide the science knowledge base need to assist police and decision makers in order to co-define adaptation mitigation pathway that should be effective in reduce the impact of fire events in the short and the medium term, also under a changing climate. So here are listed our main activity, let's say. So we aim to define the fire risk hotspot and exposure mapping under different climate and management and adaptation scenarios. And this will be done, hopefully, in cooperation with IASA. We will identify, in order to do this, we will identify the fire smart solution that could be implemented there. And then we also evaluate, we aim to evaluate this fire smart solution in terms, for example, of fire size, flame length, emissions, natural capital, in order to understand which solution is viable. Then we aim, together with Confagricoltura, to engage and involve stakeholders in the co-design of this adaptation and mitigation pathway. And we hopefully, together with IASA and HuT, we would like to provide or to translate this information, these maps, in new insurance products. So here, more or less, I already said what are the development that we want to achieve within the project. So co-definition of adaptation pathway, new type of finance product, and first strategies to integrate disaster risk reduction and climate change adaptation. And the main end user will be the local municipality, the different type of forest ranger, we hope, but also all the touristic facilities. So in this table, there are we listed the activity from table 2 in the grant agreement, and our actual commitment. So as Guido said, we probably were very enthusiastic when we wrote the project, but we are quite confident we can achieve all these commitments together with the partner in red on your left, but on your right, actually. But maybe the most challenging activity for us will be the one related to the insurance product. So during the speed dating, we need to talk about this with the partners that deal these activities. So the final slide, the HuT footprint. Our expected results are very, okay, during the project implementation, we hope to obtain, we are quite confident to obtain fire risk hotspot and exposure mapping. We aim to identify through the co-development with stakeholder different management and adaptation scenario, evaluate those management and adaptation scenarios in terms that are quite important also for ecosystem, for the ecosystem services and natural capital. And this is, I should have had a question mark here, fire hazard product. Okay, I'm finishing. Concerning the outcomes, we want to increase the risk awareness among stakeholders, including also the tourists, improve the dialogue and the cooperation among the scientific and technical communities, and contribute also to the co-development of potential fire prevention strategies, including nature-based solution, and probably providing the local government with this solution that could be help also in the drafting of the climate change adaptation, regional climate change adaptation plan. And the long-term impact, we aim to increase local understanding and knowledge of disaster risk reduction, increase multi-stakeholder coordination, and transfer this approach to bridge climate change adaptation and disaster risk reduction. And thank you.
Oops, thank you very much. We move on quickly to number 9. DEM 9 is BGS, Dorset County. Run.
Running back that way. Okay, good morning, everybody. So BGS are joint leads on Demonstrator 9 with the Met Office, so with Joe Robbins, who unfortunately can't be here today. So Dorset County is located on the south coast of the UK. It forms the UNESCO World Heritage Site, and that's to do with the geology. So it's got a complete sequence of Triassic, Jurassic, and Cretaceous strata across the coastline. It's a tourist location with a high economic value. So in 2019, it was 1.8 billion was the tourist revenue, 300 million visitors and 41,000 jobs. Obviously slightly different after COVID, but they're the numbers we're going to use for this. So it's got a varied inland and coastal landscapes, and the Dorset Local Resilience Forum separate the hazards into severe weather hazards and environment-related hazards. So it's severe weather-related hazards are flooding, wind, heat, and rockfalls. And the picture on the top right for you up there is the sad event in 2012 when a lady was killed by that particular rockfall. Their environment hazards that they list are flooding, fires, and rockfalls, again. So there's a bit of debate as to whether it's a weather hazard or an environment-related hazard, the rockfall situation. So under this demonstrator, we would like to investigate the best ways to consolidate existing monitoring and forecasting tools to enhance communication and dissemination of information and multiple hazards to stakeholders in the area and the public. So in terms of the institutional setting, BGS are leading this with the Met Office, as I said. So BGS, with the National Geological Survey, hazards, landslide expertise, flooding a little bit at the coast. We've got technologies that we're trying to improve, so Internet of Things and Earth observations, and citizen science, risk reduction, interest. The Met Office themselves are looking at the forecasting. They've got expertise in the waves and the heat wave, and some drought and wildfire might creep into the HuT experience depending on how we get on over the 4 years. Bournemouth University are key for us in terms of their Internet of Things expertise, and of course links with Dorset Council, the unitary local authority. We also have Joe and I both have very good links with the National Hazards Partnership. We're both members of the Hazard Impact and Science Group, and we will be engaging them in terms of my timer didn't start, engaging them as the project continues. We've also got links with key local responders with the Fire Service, the Coast Guards, Local Resilience Forum, and Dorset Prepared organisation. The BGS and the Met Office will be explaining new approaches to monitoring and forecasting, but the move to the uptake of these and the communication will always remain challenging. So in terms of the key innovations already in place, we've got the Internet of Things technology, and I'll talk about this a little bit more in our next slide. We've got the National Landslide Database, which I manage at BGS. We've got improvements in weather forecasting and data sets, and we've got a good history of collaboration with resilience partners in the Dorset area, including response visits for the 2012 rockfalls, the BGS Fire Service support, where they wanted to know how, if they were responding to landslide hazard at the coast, how they could look at which areas, for example, where they could park their fire engines, how they could access the site safely, whether they could assess whether there was a potential risk of more rockfalls in an area. We've got partnerships in severe weather events, so we're part of a group that if they have a severe weather announcement on the south coast, we get involved and they talk to us about landslide hazards. And of course, the Met Office local forecasting, hazard impact-based forecasting that they're doing their research on. So in 2012 summer, the heat wave was the first time that BGS actually issued their first blog and press announcement based on rockfalls at the coast, and just asking people to be a bit aware because this is a very key picnic site, and generally people picnic right underneath the cliffs on those pictures. So as I mentioned yesterday, the Rural 5G project was focused on the south coast. So we've got two cases of landslides examples here. You've got the big Black Fen rotational landslide, which is at the bottom of Lyme Regis Town Centre, and then the big rockfall events that on this section of coast is very prevalent. So as part of the 5G rural project, 21 GPS sensors were deployed in the Black Fen landslide and the Burton Cliffs. And like I said yesterday, most of the lessons learned from this project were associated with connectivity, and we're hoping to improve some of the technology that's going out as part of this project as well. So in terms of my normal job, this is kind of where I'm involved normally. So the daily landslide hazard assessment. So BGS are involved in applying a hazard assessment to the Natural Hazard Partnership that goes out daily to Category 1 and Category 2 responders in the UK. So we have quite a good system for Scotland, but not so good in the South Coast in terms of the fact we haven't actually got the models built for the South Coast. We've got susceptibility maps for the whole of the UK, but obviously the area that we're looking at has got a coastal environment, and this changes the susceptibility at the coast and is not as well mapped in terms of our mapping. We have a very high social media presence, so this is where we gain most of our data from in terms of recent landslide events. which I know is controversial to some people, but some data we think is better than no data. But of course, this also biases our models, because often you tend to hear about a landslide that has had impact, whereas actually you also need the ones that have no impact in order to verify your susceptibility models. So in terms of the HuT project, one of the things that we're looking at, it needs to be, our assessments need to be better supported by modelling and local forecasting, which is where Joe comes in. The coastal hazards need to be better covered, and we need to have a separate, perhaps, warning system for the coastal sections, which is being talked about as part of the Natural Hazard Partnership anyway. And we need to be better at clarifying and contextualising impact in the area. One key thing to say is that the actual daily hazard assessment, which covers all the hazards in the UK, and I'm happy to talk about that if you're interested in the demonstrator area, does not go out to the public. This is Category 1 and Category 2 responders only. So this is where we come on to Joe's research. So apologies for me presenting it. So one of the key issues that we're trying to understand is the impact of heavy rainfall. So as part of the Natural Hazard Partnership, one of the models, the impact models, is the surface water flooding impact model. So this provides challenges for forecasting communication. So with both flooding and landslides, one of the key forecasting issues for us is convective rainfall. We're very good with antecedent conditions and forecasted rainfall, but knowing where and when and how much rainfall is going to fall in advance in a convective rainstorm is spatially and temporally difficult. But this can still result in a large difference in the risk and impact severity in a local area. So this is where we're going to look at what information is available to issue to users in a timely manner and how we can do this in a better form. So impact is going to form a big piece of the work for us. In terms of the current streams of hazard information, warnings and guidance, I've already mentioned the daily hazard assessment that goes out every day to Category 1 and Category 2 responders. The Met Office have their local public service weather forecasts as well that can be accessed by most people in terms of the Hazard Manager website. And they have specific information on flooding and other marine forecasts that they work with the beach people, beach users, beach people. And so that they have local collaborations for hazard assessment already. So the provision of hazard and impact-based forecasting is also very well covered, but like somebody was saying yesterday, it's disparate information streams. It's not all combined into one set. And one key is the timeliness, accuracy, and detail of those information and what the messaging is and how it can be included for different users. So in terms of our demonstrator innovations, our core science questions for the study. We're very interested in looking at the value chain approach and looking at where the bottlenecks and where the issues are and the challenges are for hazard forecasting. We'd like to consider how the nowcasting and weather forecast approaches can be utilised better for hazard and impact assessment, and what impacts can be witnessed from flash flooding and slope failure in the current demonstrator area. The key features of this will be Internet of Things, which I keep saying will be developed, but is not as far as we wanted it to be at the beginning of this project, and the value chain communication, which Joe will be leading on. And one of the things we're really interested in is the methods to integrate communication and dissemination within the timescales and the hazard scenarios. So in terms of the HuT footprint, we've got expected results immediately from the project implementation, and that includes the Internet of Things shared learning, please, if people are interested in that, the review of the value chain concepts and improved understanding of current forecasting capabilities. We've then got medium-term analysis, so analysis of the Met Office data and improved knowledge of multi-cascading hazards within the region, and then the longer-term impacts of communication and comms. So one key thing for us to say is that when we're answering our core science questions, how can the nowcast and weather forecast approaches be better utilised, and how can we better understand impact in the area? When we're moving towards better communication, this might not actually be warning, but it might be improved educational material and resources. So I'm quite interested to talk to the communications people who are doing things in a slightly different way, because in Dorset particularly, there were plenty of signs for rockfalls with people sitting underneath them. So how we can do that in a better way, and one discussion has been QR codes that we could introduce at the coast. And that's it from me. Thank you very much.
Thank you. And then last but not least, DEM 10, we move to Switzerland.
Yes, buongiorno. I will be very quick. We have the burn demonstrator as our catchment. And yeah, it's important that we have already worked together with the canton of Bern in another EU project called Anywhere, where also Arantec and UBC have taken part. And of course, you know where Canton Bern in Switzerland is. Now, the institutional setting for crisis management in the Canton Bern and in Switzerland, I don't want to go into the details, but perhaps important, we have a national emergency center with 2 tools, Avarna and GIN. And we have, for example, in some valleys of the Canton Bern, we have a valley task force with a risk disaster consultant. Now, what are our ongoing activities? Some selected examples. One important point, which was mentioned also by some of you, are these cascading effects. And here in the Canton Bern, in the Zug Valley, we have quite often such cascading effect that we have convective, strong, heavy precipitation, intense precipitation, that we have a mobilization of wood, and then this wood is further downstream, then congesting at Wers or so, and is then leading to a flood downstairs, for example, in the capital. That means not there where the heavy rain really was, but several kilometers downstream. So this is a typical example of a cascading event. Then decision under uncertainty. Here, an example under decreasing uncertainty with decreasing lead time, which is typical for advective events, of course. And here is, it's important that you have a look on the lowest part of the graphs, because here we have the leveled approach, also mentioned already by some of you. That means we are proposing pre-alert, alert, warning, alarm. This is another topic we have already worked in. The medium-range forecast of rain and snow events in pre-alpine areas. This is typical for pre-alpine areas in Switzerland or in other parts of the Alps. And it's also typical for an impact forecast. For example, if we have 30 millimeters of rain forecasted, this is a level 3 warning in Switzerland by Meteo Suisse. But most of the time, there are not really big consequences, let's say perhaps local consequences. But if then additional to these 30 millimeters of rain are coming 30 or more millimeters of snow melt, then we have, of course, a heavy impact. So this is really important to take these processes into account. Okay, innovations to be carried out, selected example. I will go to the examples. Yes, not mentioned very often today. These are the serious games. And this is a game, serious game, which was developed in the frame of this mentioned Anywhere project, and it's called AnyCare. And of course, these serious games are also a topic in this project. And we would advise to really, that we really base ourselves on the serious games already existing. Yeah, this, let's say the example is an example where I was involved for about 10 years for the canton of Valais. In the canton of Valais, we have dammed lakes, and there is a process to lower the level of these dammed lakes to offer space for the flood and to protect the down valley area. But of course, then the canton has to pay to the energy company the lost money. And for example, in this year, if you would pay it really in market prices, this would cost by, if you lower them by 20%, up to 500 million euro. What type of warning messages lead to effective response? That's the use of new technologies to improve social response capacity. This topic where mainly my colleague Anna Skolobik is involved. Yeah, what are really warnings which are effective, which are responsive, etc., etc. Yeah. Now, also sometimes mentioned, and I also mentioned it before, but we did a paper about these cascading effects. And this is an example of this cascading effect in the Zug Valley. I have already mentioned, but we mentioned this paper also a freezing rain event in Slovenia and a snowfall event in Catalonia. This is another graph from this paper, from this publication, how a triggering event, which is, for example, not very serious, it can be not very serious, also let's say 30 millimeters of rainfall, but this rainfall is then iced when it hits the soil, and the effects can be catastrophic. Another question, what are the enablers and barriers to multi-hazard systemic risk reduction? Here we plan to work together with IASA, sorry. The footprint of the burn demonstrator, I want only to mention these 3 points. From variable threshold to warning, also to impact forecasts. I've mentioned these examples of these 30 millimeters of rain, which can be added by snow melt, or which can be much more serious because of freezing rain. Then also mentioned the second point, from single event forecast to compound and cascading event forecasts, and from single risk to multi-risk and people-centered early warning system. Yes, I won't go in the details here. You can meet us at our poster and also at the speed dating. Thanks a lot.
Thank you. Thank you very much. Guido, come up. So we ended the presentations part of this morning, and we are late as we on schedule because we started late and we kept that delay. Anyway, what's the timing now? Yeah, about 11 o'clock. So we are supposed to start right now. It's impossible to start right now yet. The coffee break is outside. My suggestion, and actually my plan is this one. You take a coffee, you take something, and somehow you make it up. particularly the first 5 demonstrators that you know, they are them 1 UPV, them 2 UPC, them 5 Aerion, them 7 Kotivizig, and them 9 BGS. They should be at their locations as soon as possible, let's say in 10 minutes. And then we just shortened by 5 minutes the speed dating part. So 40 minutes plus 40 minutes instead of 45 plus 45. So we go, and then at some point, I will tell you that the time is over for the first round, we move to the second round. By now, I'm assuming that you read the instructions. Anyway, you read the instructions, but I want to tell you, on the tables, you will find one of these, and it's your own dedicated table. Table 1, possibility to update table 1, you will find one of these. Then you will find, you will find three of these to take notes, and at the end, as we said in the instruction, we will collect all this material. You will find some A3 blank sheets if you need to write something else. You will find all the posters already set up. You will find a pen, a marker, nothing else. And I don't know if Guido wants to add something.
No, only to recall that for this one, you should take note of all the interactions in different speed dating phases that you have in the first and second and third round. So to have a better idea about which type of interaction can work or not. And so this is a sort of working document that you can use. Otherwise, the other documents should be a sort of summary at the end of the speed dating stages, okay? That's all.
Yes, indeed, working document, summary. Anyway, we collect everything at the end. And anyway, it's an experiment for the consortium, for the HuT. We have the internal innovations fair. Let's see how it works. With the feedback, we will improve for the next fairs. Thank you very much. Get your coffee, get up. Thank you very much.